Hey, so in this video I want to introduce a few more things to you that were introduced in C++ 11. Firstly, we have the auto type. Now the auto type deduces the type of the variable from the expression following the assignment operator. So you can see we have auto instead of int or float, and then the variable name, so in this case demo variable, the assignment operator, and then some expression. And it's typically used in range-based for loops. So as you can see here, we have the demo array, which contains integers, and then we have the range-based for loop, and instead of using int, we use auto. And the type of variable that will be deduced here is, of course, integers. So we'll see a few examples in Visual Studio shortly. Then we have this decltype or declare type specifier, which is going to yield the type of a specified expression. And this is a declaration. You can see decltype again. We have the parentheses 5 divided by 2.5f, so that is a float. And then we specify the variable, so in this case x, end that off with a semicolon. So x will be deduced to be of type float in that case, because it's going to use floating point division and therefore return from that a float. And then from that expression it's going to declare x to be of type float. We go and initialize x, and then we print x out. So with auto, we have a declaration and an initialization. This decltype, or basically declare type, is a declaration, right? It determines the type for that variable, but then you still go and initialize it after the fact. You might see it somewhere or you might find it handy, but again, personally, I don't really use this one. For the most part, I use auto. Right, so I'm not going to demonstrate the declare type for you. That's basically done already in the slides. You can go and experiment with that, but I'm going to show you the auto. So this right here, auto x is equal to 5, is similar to this, int x is equal to 5. Build around that and you can see we get 5, and the size of x is 4. If I go and do auto x is equal to 5 divided by 2.5f, we should get a floating point. So we get 2 and we get 4 once again. But if I remove that f, we get a size of 8. So that's a double, right? So once again, I'm just using the size of to do that, of course. Here I'm printing it out, and here I print out the size of. So you can see that this will deduce the type of x, but it is also going to assign or initialize x. So it's a declaration and an initialization. So one thing to note is you don't have to do the size of really. If you want to see the type, it doesn't show you exactly the type anyway. It just shows you the size, right? Now in Visual Studio I have these helpers, so what you can do is you can hover over the variable. So in this case x, you can see currently this is a float, so float x. If I remove that f and hover over x again, this is now a double. If I remove all of that, then x will now be an integer. Size of, if I hover over x, once again we get double. So remember the helpers, really handy way of seeing what is going on. So auto is typically used with the range-based for loop, as I mentioned. You have this demo again. So instead of doing int here, you can change that to auto. And you can see that this works fine. So auto is especially useful if you have really complicated types. Now at this point we don't really have custom types and we are not working with really complicated things, templates and all of that stuff. But auto is still handy and you will see it in other people's code and you'll probably use it more and more as you go along. Auto can also be used with other container types, of course, not just with arrays. So you can use them with the range-based for loop to loop through vectors and so on, as we'll see in the next module. So what's nice about this is, let's say later on I go and change this to a float. Now I can change that in one place. So I can just change it up here and I don't have to go and look for that for loop. This works fine. I did not have to go and change this here. I changed it in one place. Okay, so that's very handy. It saves you time. Let's say we know ahead of time what our list will be, and we don't want to go and create an array like we did here. We can cut that out. And I'll pass it in like this. Build and run that, and you can see that works fine too. So the syntax might be weird, but basically we have some list here, and we are just iterating through that each time. You can also loop through strings. Okay. Now it will go and print out each character. So a string is a collection of characters, right? We'll talk more about characters, character arrays, and strings in module 102, mainly because strings are not simple types like int, float, and so on. Some of the types that we have in this module. We have to learn object-oriented programming first, member functions, and so on. Then we'll talk about strings in more detail. But one quick demonstration. So right here, if x is equal to a character here that has this space, so if it has a space, then print out an underscore maybe. Instead of a space, we print out an underscore. Else we print out x. I'll just remove that space, build and run that. And now instead of having spaces, we have underscores. Of course, you can go and add another inline to move the stuff down. Just a quick demonstration, some string manipulation. Again, we'll cover strings and characters in more detail in module 102. Alright, I hope you found this useful, and I'll see you in the next lecture.